Warm-up 111 is done. Thank you for sending that in. And so today we're just going to add a couple more things to what we've been doing so far with the graphing before we move on. So copy the agenda, please. Warm-up 111 done. Rational functions. And tonight's home play, 4 cumulative review problems only. Now, hopefully we have enough time at the end so like that you can team up with your neighbor and finish those up here before you leave. Like I said, we're just going to add a couple more things to the graphing and we'll be done with this part of the section. Once again, warm-up 111, rational functions, 4 cumulative review problems only tonight. All right, the code to access the home play, EKMTV, EKMTV. Write that down, please, EKMTV. All right, so last night's home play. Get that out and show it to your neighbors to see if they have something similar to yours so far on that work. Then from there, get a Cornell note ready, please. All right, so I can write, solve, and graph rational functions. So right now we're focused just on the graphing portion, okay? So, remind your neighbor what rational functions are. See if you remember a definition in your own words. Definition in your own words. What are rational functions? So, equations that contain one or more rational expressions or one or more fractions. We have those notes already. You don't need to rewrite them. We also wrote steps for graphing and steps for writing an equation from a graph. And from there we went from a general rule to our rational rule. And we see that the parameters are all the same. And then from there we talked about vertical, horizontal, and diagonal asymptotes. And right now we're in the middle of vertical asymptote and horizontal asymptote. We did the simple ones for a couple of days. Then we went to these for a couple of days. Then yesterday we started with these. Is that correct? Yes. And then we did some more of those. And then we ended up, I think, with this one. Is that correct? Check your notes really quick. Do you have that one, Joseph? Oh my goodness. Bah. Do you have that one, Joseph, in your notes? What? You don't have that one? Oh, okay. All right. So, send me a picture of that one on the screen. Let's see if it's true that you have it. Oh yeah, I got this. I'm in the year 2030. Let's go. Huh, Mariah? So, we're moving on to the next one. Here we go. Write that one on your notes, please. Example 1, Michael Jordan Q. And this is the one that we're going to do together that is going to have a couple more things that I want to add to the whole section. Example 1, Michael Jordan Q. Rewrite the function and graph, then identify the domain and range. And I don't know if you guys noticed, we haven't been writing the domain and range. All right. So, first things first. Does this have a 1 on the numerator? No. So turn to your neighbor, remind them what to do from here. What do we do from there, please? All right, do that step, please. Whatever your neighbor told you to do, as long as it's correct. All right, so what do I do? Mario, pass on one. Joseph. Divide. All right, so we got 10x minus 8 divided by 2x minus 1. All right, help me out. Joseph, what number times 2x gives me 10x? 5. So 5 times 2x is 10x. 5 times negative 1 is negative 5. And once again, guys, avoid this mistake. We need to subtract. So when you circle it, remind yourself to distribute here and here. Because last time I saw some of you make that mistake. So these cancel. Negative 8 plus 5 is negative 3. All right, so the answer to that division is 5. But since we have a remainder, we are at negative 3. And the divisor is 2x minus 1. All right. Tell your neighbor what to do next so that we can continue rewriting that equation. Please turn to your neighbor and let them know exactly what to do, please. Joseph, have someone? Mario.
No. Oh. 30.
Circle. Okay. And this goes to the back. Okay, so then we got plus 5 in the back, and we're left with negative 3 over 2x minus 1 in the front. So far, so good. What do I do next? Tell your neighbor, please, and then Mario's going to pass him one. Mario, pass him one. Mariah. What do you notice we have in the numerator? We have a negative 3, but what needs to be in the numerator? A 1, so what do I do with this? Yeah, move it to the front. So that goes to the front. So we got negative 3 plus 5 at the end. And what do we write on top, guys, once we get that number out? A 1. And all that equal to g of x. All right. So far, so good. Next, we need a VA. Tell your neighbor how to find the VA from here, please. Talk it over to your neighbor. Make sure they got it. Mariah, pass them one. Who? Enrique, what do I do? Yeah, set it equal to 0 and plus 1 plus 1. 2x equals 1. Divide by 2. X equals 1/2. 1/2. Okay. Our HA, which is f of x, is equal to the constant, which is 5. All right, let's graph that really quick. We got 1/2 of x, about right here. we have 5 of f of x, or g of x. All right. So we're getting ready to graph our function. However, this time I want us to graph it without a table. How about them apples? All right. So let me write the function over here so we can have it in next to the graph so you guys can see exactly what we're doing. -3 times 1 over 2x minus 1 plus 5. Okay. So, according to what we saw yesterday, look up to the screen, guys. Yesterday we talked about how we have a vertical asymptote and then we have a horizontal asymptote. Is that correct? And then we noticed that when we graph, there's usually a point 1 step to the left and 1 down, 1 step to the right and 1 up. That looks something like this. Is that correct? All right. However, yesterday we mentioned that if we end up with an equation that has this number in the front, so now instead of being the graph at 1 to the left and 1 down, and 1 to the right and 1 down, what do you think is going to happen now with that point from the center of the asymptote? And once again, we're talking about center as the asymptote. Let me zoom in. Being here. This is the center of the asymptote. So if there's a step, 1 to the left, 1 down, 1 to the right, 1 up, what's going to happen to that? Talk to your neighbor. What's going to happen to that? Where's that point going to be at? Thinking cap on. All right. Good thinking. Let's go with Caesar. What do you think, Caesar? If I was to plot a point starting from here from the asymptote, I go 1 to the left, and then what do? 3 down. Woo. Let me zoom in. So 1 full step from the half, if I go to the left, I'm at -half, and 3 down. 1, 2, 3. Okay, plot that one yourself. And then 1 full step to the right from the half, we should be at 1.5, and 3 up, 1, 2, 3. So there's my point. Don't graph your function yet. But so far, is everybody following so far up to right there? Yes? Okay. However, look up. What else is in the front of that function? Tell your neighbor. What else is on the front? Edwin, what else is in the front? All right, so what happens to the entire function according to that? Talk to your neighbor, people. What happens to the entire function? All right, let's pass it to Renzo. What happens to the entire function with that? That's true. So instead of the point being down here, now we're going to move it where? Up there. And this one, we're going to move it down here. So let me zoom out. So now our function is looking like that and like that. And notice we just graphed it without a table. All right, before I move on, talk it over your neighbor, make sure they understand how to graph without a table given the parameters, please. Talk it over your neighbor, please. All right, thank you for sending that in. Okay, we're good, right? All right, so now let's talk domain and range. On the side, I want you to write D for domain, which means what X values are being used for the graphs. So, look at the X values. And what X values are being used to graph this. And remember, the arrows means that it continues going in that direction. What X values are being used and which ones are not being used. Talk to your neighbor. Which ones are being used and which ones are not. Which X values are being used. All right, let's see. Get us started, please. Renzo, pass on one. Elijah. So if I was to ask you for the domain for this little curve over here, what X values would you give me? All the negative ones, all the way up to where? Up to 0? Up to the 1/2. That is correct. So therefore, my domain would be X has to be what? Such that what values for X you said? All the negatives from the 1/2. Is that correct? So X has to be less than 1/2. Now notice I didn't write the little equal sign because it does not include the 1/2. Does everybody understand what we're doing here? Okay. However, comma, what else, because that's only for this one, tell your neighbor what would be the domain for this part. Talk to the neighbor, what would be the domain for this part so we can add it there. All right, Elijah, pass on one. Joseph. X is what? Yes, greater than 1/2. So X is less than 1/2 and greater than 1/2, but it's not including it. That's why we don't write this. Look up. We don't write an equal sign here or here because it does not include the 1/2. All right, not bad. So we got the domain. Let's go with the range. And in this case, the range is g of x, so we're going to write g of x such that, all right, so let's see. Once again, I'm focused on this one right here. And I'm focused on the y values. So to graph this piece right here, according to the y values, tell your neighbor what y values shall I use for that. All right, looks like Mario's got it. All right, Mario. G of x is what? Five, okay, but what? Equal, greater, or less than? Very good. Greater than 5. So to graph this piece, anything above 5, that is correct, comma. And to graph this one, tell your neighbor what would be the range for that piece. What would be the range for that piece? G of x is what? Pass the one, Mario. Enrique. Bless you. What is it? Less than 5. Double check. Is this graph appearing less than the 5? Yes, and it's going to continue going all the way to the infinite. That is correct. All right, so for this next problem, I want to see the domain and range aside from graphing it without a table. All right, so copy this one again, example 1 super duper Q. Do that one by yourself. Again, even though we already did this one yesterday, but we did it together, I want you to do this one completely by yourself and graph it without a table. Go. All right, let's see. Get us started, please. What do I do first, Caitlin? What do I do? Divide 12x plus 7 divided by 3x plus 1. What divides in there, Caitlin? 4. 4 times 3x is 12x. 4 times 1 is 4. Subtract. Once again, I asked you to circle it and distribute here and here so you won't make a mistake. So therefore, you end up with positive 3. Hands if you got that. All right, pass on one, Caitlin. Joseph, so if I have 4 plus, then a fraction bar, then I got the 3, and then 3x plus 1. What do I do from there? In the back, and then we end up with 3 over 3x plus 1, and then? What? We still have a 3 on the numerator. We only need a 1 on the numerator. Yeah, that goes in the front. Times 3x plus 1 plus 4. And what do I write on top? 1, and all that equal to g of x. All right, hands if you got that by yourself. All right, so from there, we do need a VA and an HA. Tell your neighbor what you got for the VA and HA. VA, HA. VA, x equals, and HA, f of x equals, or g of x. All right, so what is our VA? Joseph, pass him one. Enrique. Minus 1 over 3. That is correct. How about our HA, Enrique? Yep. All right, let's graph that. So we got 4. And then we got negative 1/3. And now we're ready to graph. Okay. So, here's the center of my asymptote. Right there. Let me zoom in. All right. So, let's pass it to, how about, why haven't we called on in a while? Monse? All right, Monse. So according to our function, what is in the front of our function? It's a 3. Okay. So, where do I place my point from the center of the asymptote? So 1/3 to the right, or 1 full step to the right. So we're at negative 1/3. So we go that direction over here to about right there. And 3 up, you said? That is correct. Right there. All right. Where do I place another one? Pass on one, Monse. Mighty. If I go from here, where do I go now? To the left. And then? Can't hear. 3 down. 1, 2, 3. That is correct. Let me zoom out. And now our graph should look something like that. Without a table. All right, we're almost done. We need a domain and a range. All right. Domain, my name, pass on one. Joseph? All right, Joseph. So to graph this piece right here, what would be my domain? What x values do I use? Negative 1/3, yes. And what? And for this piece? That is correct. Hands if you got that. All right. And the range. G of x. So G of x is what? Tell your neighbor what you got for the range. How do we get this piece on top and this piece on the bottom? Talk to your neighbor, please. How do we write that as the range? All right, pass someone. Joseph. Mariah. For this piece, from where up? G of x is greater than what? Than 4. That is correct. Or G of x is less than 4. All right, send me your notes, please. And we'll stop right there. Those of you that are following along, make sure you put some practice in tonight. There's only 4 problems tonight for graphing, guys. I want you to graph them without a table and write your domain and range, please. All right, see you guys next time. Peace.